This short presentation, which I titled Time at Sea, the Foundation of Navigation, welcome the freshman students, the future mariners. One of the first concepts that must understand is the importance of time in navigation. Time is much more than reading a clock, it is the key to determining a ship's position, calculating longitude, planning voyages, and communicating with ships and ports around the world. In this presentation, we will learn how the Earth's rotation creates different time zones and explore the concepts of Universal Coordinated Time, or UTC, Local Mean Time, or LMT, and zone description. As shown in the illustration, the Earth rotates 360 degrees in 24 hours. This means the Earth turns approximately 15 degrees every hour. This relationship forms the basis of all time zone and longitude calculations used in marine navigation. Since 1 hour equals 60 minutes, dividing 60 minutes by 15 degrees tells us that 1 degree of longitude corresponds to 4 minutes of time. Similarly, each degree contains 60 minutes of arcade. Dividing 4 minutes of time by 60 gives 4 seconds of time for every 1 minute of arc. These simple relationships are extremely important because they allow navigators to convert longitude into time, and time back into longitude. This picture is a world time zone map. It shows how the Earth is divided into 24 time zones, each generally covering 15 degrees of longitude, and how local time changes as you move east or west from the prime meridian, 0 degrees longitude. As you travel east, local time becomes later because the Earth rotates from west to east. Places to the east see the sun earlier than Greenwich. As you travel west, local time becomes earlier because those places have not yet rotated to face the sun. Remember this simple rule: east is positive and ahead of UTC, while west is negative and behind UTC. This principle is fundamental to understanding zone description and converting between local mean time and UTC. In order to obtain UTC, apply the longitude in time to LMT as follows. GMT or UTC equals LMT plus or minus longitude in time. Add west minus east. Mnemonic to remember. Lego minus. LMT to GMT, east minus. GEL plus. GMT to LMT, east plus. AT divided by 15, arc to time. Longitude divided by 15. TAX 15, time to arc, longitude times 15. Explanation of the illustration. This illustration presents a navigation exercise in which the ship's position, date, and local mean time, LMT, are given. The objective is to determine the zone description, ZD, and the corresponding Universal Coordinated Time, UTC. Given information. From the illustration, we can identify the following parameters. Date, July 8, 2026. Local mean time, LMT 10 hours 20 minutes 0 seconds. Ship's position. Latitude, 10 degrees 24.0 foot north. Longitude, 124 degrees 6.0 foot east. The red rectangle highlights the ship's position, while the blue line represents the ship's track or intended movement. The nautical chart provides the geographical location where the navigation problem is based. Understanding the problem. The purpose of this exercise is to use the ship's longitude to determine the zone description, ZD, and then convert the given local mean time, LMT, to Universal Coordinated Time, UTC. Since the ship is located at 124 degrees 06. 0 foot east longitude, it lies east of the prime meridian. This means the ship's local time is ahead of UTC. Let's solve this example to determine the zone description, or ZD, and the corresponding Coordinated Universal Time, or UTC. We are given a longitude of 124 degrees 6.0 minutes east and a local mean time, or LMT, of 10 hours, 20 minutes, and 0 seconds on July 8, 2026. Our first step is to calculate the zone description. The formula is zone description equals longitude divided by 15 degrees. We divide 124 degrees 06. 0 minutes by 15 degrees because the Earth is divided into 24 time zones, each covering approximately 15 degrees of longitude. The calculation gives 8 degrees, 16 minutes, and 24 seconds, or approximately 8.27. Since zone descriptions are expressed as whole numbers, we use the nearest standard time zone, which is zone 8. Because the longitude is east of the prime meridian, the zone description is negative. So, the zone description is -8, written as ZD equals -8. Next, we convert local mean time to UTC. A simple memory aid is LEG, which stands for local mean time, East, Greenwich. This reminds us that when converting LMT to GMT or UTC, we subtract the zone description for locations east of Greenwich. Starting with the local mean time of 10 hours, 20 minutes, and 0 seconds, we subtract 8 hours. The result is 2 hours, 20 minutes, and 0 seconds. Therefore, the UTC is 2 hours, 20 minutes, and 0 seconds, on July 8, 2026. Starting with the local mean time of 10 hours, 20 minutes, and 0 seconds, we subtract 8 hours. This gives us a UTC of 2 hours, 20 minutes, and 0 seconds, on July 8, 2026. On the right side of the slide, we can see an online UTC time zone converter. The converter shows that when the local time is 10:20 a.m., the corresponding UTC is 2:20 a.m., which matches our manual calculation. This confirms that our computation is correct. This